Hello boys and girls, welcome to yet another fun and exciting lesson in science in daily life. I am your teacher, Sir Zamin. Today, we have a lot of work to cover, but before we get into today's lesson, can you recall what we would have done in our previous class? Yes, we would have looked at series and parallel circuits. I do hope you had the time to carry out the investigation that I said to you in our previous class. In today's lesson, we will look at electricity in the home. Our objectives for today are to describe the heating effect of electricity and to discuss electrical safety. Electricity is very useful. It is also quite easily moved from one place to another by means of cables, such as those which bring electricity into our homes. The energy is then available to us at the press of a switch. It does not have to be stored like coal, oil, or gas. It is clean and quiet and can easily be changed into other forms of energy, such as light, heat, sound, and mechanical energy. But, boys and girls, household electricity can also be dangerous. The electricity which is supplied to our homes and schools is at a much higher voltage than that of an ordinary cell or battery. If our bodies should come in contact with such a high voltage, we can receive a severe shock and burn. The heating effect of electricity can also lead to fires. Many fires are caused by faulty electrical wiring and appliances. It is therefore necessary to follow all precautions when handling electricity. You must protect yourself, others, and the surroundings. Remember, boys and girls, electricity can kill. Let us now move on to the heating effect of electricity. We have already mentioned that an electric current can produce a heating effect. This effect is very useful in, say, an electric iron, but it can also be a nuisance. For example, in heating the cables through which an electric current flows. Now, we can demonstrate in the lab how strands of steel wool can be burnt owing to the heating effect of electricity. Boys and girls, I caution you, if you were to do this in your home, please do it around a parent or a guardian. Here you have a circuit that is being set up to demonstrate the heating effect of an electric current. A flying lead is connected across the bulbs and can be made to touch some strands of steel wool connected in the circuit. What happens to the steel wool and to the bulbs? What do you think will actually happen? Yes, you will see the steel wool starting to glow, which would have indicated that it is being heated up. Now, if we're to replace the steel wool with a piece of a thin wire, we can call that wire a fuse wire, and connect the battery directly across the fuse wire so that a heavy current passes through it, what do you think will happen to that wire? For the fuse wire to melt, it must have gotten hot. Therefore, the electric current passes through the wire to make it hot. The soft, thin fuse wire is made up of tin and lead, two metals which can melt easily. Now, boys and girls, many appliances in our home make use of the heating effect of electricity. Can you name a few of those appliances, apart from the iron in which we would have mentioned? Yes, we can have the electric kettle or even the electric lamp. An electric lamp glows because the current passing through the wire in the lamp makes it get hot. The same current flows through both the wires and the lamp. But why do you think only the filament in the lamp gets hot? The reason is that the filament in the lamp has a higher resistance than the connecting wires. The electric kettle and the electric cooker are some appliances which use the heating effect of an electric current. Okay, boys and girls, let us now look at a video to show you the heating effect of electricity. Do enjoy.
Applications of heating effect of electric current. Electric current gets converted into heat energy when it passes through an electric stove or oven, radiant energy in a bulb, and into chemical energy when a storage battery is charged. Let us see how some appliances get heated up when electricity passes through them. When electric current flows through a conductor, the conductor offers resistance to the flow of current. The work done in overcoming the resistance appears as heat energy. Electric irons, kettles, cookers, ovens, immersion heaters, etc. are appliances which make use of the heating effect of electric current. These appliances use nichrome as the heating element because it offers high resistance to the flow of current and has a high melting point. Electric iron. Let us now learn about the working of an electric iron. The prime requirement of an electric iron is the uniform distribution of heat over a large surface. A metal which is a good heat conductor is used as a base. The metal base is generally chromium plated to make it smooth and withstand wear and tear. The heating element is wound round a flat sheet of mica and is sandwiched between two thin insulating sheets. Mica is chosen as insulating material because it is a bad conductor of electricity but a good conductor of heat. Moreover, it has a very high ignition temperature which prevents it from catching fire. To prevent the upward flow of heat, it is covered by asbestos on the upper side. As a result, all the heat produced is passed on to the base. An automatic electric iron contains a thermostat which switches the current off when the temperature of the base exceeds the selected temperature. Some of the high-quality irons also have a Teflon layer on the base. This prevents the cloth from sticking to the base and getting burned. Some of these irons also have facilities for storing water for spraying. In such irons, either a nozzle to spray steam is provided or the metal base itself has that provision.
Welcome back, students. From the video, you were given examples of appliances which make use of the heating effect of electricity which we use daily. It would have also explained the application in an electric iron. However, we also mentioned that electricity can be dangerous. Hence, we will now move on to electrical safety. What is electrical safety? Electricity is very useful and can also be dangerous. Since we need to use electricity safely, we should know about the design of circuits and safety devices used in houses and how to fit fuses and plugs correctly. Now, let us talk a bit about wires. Wires, or cables as they are sometimes called, are conductors which bring electricity into our homes and which are used to make electricity to the lamp and other appliances. These wires must be thick enough not to get too hot when they are carrying the normal current. If something goes wrong with the wiring, a very large current might pass through the wires, which would make them get red hot, and this may set your house on fire. Wires carrying current in the house need to be well insulated. You may have noticed that the wires attached to appliances are covered with plastic material. Why is this so? Yes, to keep the electric current within and not to be exposed. Now, boys and girls, I'm sure if you look at some newspaper clippings or you do some research on the internet, most electrical fires, or I should say most fires rather, that are caused in homes and buildings are due to some faulty wire. So we need to be very, very cautious. If you're to examine a piece of cable, right? If you examine a length of cable, such as that used to connect an appliance to a plug, strip off about 2 centimeters of the thick outer covering. You will notice that there are either 2 or 3 smaller sets of wire in the cable. These wires have insulation of different colors so that we can tell the difference between them. All appliances need 2 wires to form a complete circuit from the source through the appliance and back to the mains. These are the live and neutral wires. The live wire is color-coded brown and the neutral wire blue. Some appliances have 3 wires attached to them. The third is known as the earth wire and is usually green and yellow or green only. The earth connection is a safety device to prevent electric shock in the case of a faulty appliance. It is connected to the metal case of the appliance. The color codes used to differentiate among the live, neutral, and earth wires are shown here in the table. So it's headed Code, Old Standard, and the New International Standard. So the live wire, the old standard was color-coded red, and now the New International Standard, it's brown. The neutral wire, the old standard was black, it is now blue according to the New International Standard. And lastly, the earth wire, the old standard was green, and it is now green or green-yellow stripe according to the New International Standard. Let us move on now to plugs. Appliances are connected to the main supply by plugs placed into sockets, also called points. There are 2 kinds of plugs. We have the 2-pin plugs and 3-pin plugs. The 2-pin plug has 2 wires, the live and neutral. The 3-pin plug has a third wire, the earth, for safety as mentioned earlier. Let us now look at the 3-pin plug, the parts of the 3-pin plug. Look at the diagram there in front of you. You can see where the 3 wires are, as well as where the cable is attached, and the fuse, where the fuse is being placed, and the plastic case. Now, boys and girls, let us look at a video on how to wire that 3-pin plug. Do pay keen attention to this video. See you soon.
I'm going to show you how to wire a plug. With the correct know-how, this is an easy job and can help to make your work area and appliances more safe and secure. And here's what you'll need to do the job. New 3-point plug, Phillips head screwdriver, flathead screwdriver, wire strippers, pliers or wire cutter. You may need to change your plug if you've got a damaged plug head or any exposed or faulty wires. Remove the old plug head by releasing the central screw with a screwdriver. Remove the cap. Loosen the 2 bottom screws to release the clamp in the plug. Remember not to unscrew these fully. Keep one of the screws connected to the clamp, remove the other screw and put it away safely. Now you're ready to disconnect the cables. Start by releasing the screws on the terminals. Now use the screwdriver to release the cables. If the wires were damaged, cut off the old wires with the pliers. If you've just damaged the plug head, it may not be necessary to snip back the wires. However, if you've any faulty or loose wiring, it's important to snip back and start the job new. So with your new plug head, keep the information on the back of the plug for when you rewire. Start by releasing the cap with the central screw. Remember to hold on to any loose screws as you will need them for when you reassemble the plug. Next, release one of the screws on the cable clamp. And now we're ready to connect our cables. using a pliers. Begin by removing the outer sheath on the cable. Carefully snip the outer sheath as not to damage any of the internal cables. You may need to indent the outer cable to release it. Next, feed your cable into the plug head, making sure there's an adequate amount of sheath for the cable clamp. First off, let's identify where each cable goes. All plug heads have internal markings to let you know which cable goes where. Brown goes to the live. Blue goes to the neutral. Green and yellow goes to the earth. Next, we need to cut our internal cables to fit their terminal length. Use a pliers to mark. Always give yourself plenty of cutting room. It's much easier to pare back if you've too much wire than if you cut too short, you'll have to start the process all over again. Next, use a wire strippers to expose about 10 mils of copper wiring at the end of each cable. To help the copper wiring fit more snugly into the terminal heads, we twist the copper wire until it's compressed. This ensures that there's no loose copper in the plug, which may lead to problems. Now, we're going to insert the individual cables into the terminals. If you need to, you can raise the terminal heads by pushing on the pins. This can make it easier to insert the wires. Once you have the first wire inserted, screw tightly to close, ensuring that there's no exposed copper. Next, insert the green and yellow cable into the earth terminal and repeat the process of closing the screw. Again, remember to check that there's no copper exposed and that PVC covering meets the terminal. If you need to, you can lift the terminal up slightly to provide ease of insertion. Although it's important to make sure there's no copper exposed, be sure not to over-insert the cable into the terminal head, as you won't provide an electrical connection. Before closing the clamp and putting on the cap, just check that each terminal is snugly in place with no copper exposed. And finally, it's important to make sure that each wire is fitted into the plug head. This will ensure that your cap will go on snugly. Now it's time to put the clamp over the cable. This clamp is to protect the cable and to prevent the internal wires from coming loose if the plug is tugged. Turn the plug and insert the second screw for the clamp. Make sure that the screw is engaging in the thread by checking it as you screw. Finally, place the cap on the plug head, ensuring it connects firmly with a click. If the plug cap doesn't fit firmly, it could indicate that some of the internal wires are over the structure of the plug, so make sure not to force it. Always check that the ampage of your fuse matches your appliance. This is a 13 amp fuse. Smaller appliances such as lamps may take a lower ampage. If you don't have the correct fuse, you're not properly protecting your appliance. Before you close the cap, give the cable a quick tug to make sure that everything is firmly in place. And to finish, tighten the middle screw to firmly close the plug head.
So my scientists, welcome back. Now you know how to wire a plug. Isn't that exciting? You can now help your parents, relatives, or friend wire a plug when needed. Students, this would have brought us to the end of today's lesson. My attentive students, today we would have done a lot. We spoke about the heating effect of electrical current, as well as wires and plugs. Do join me for our next class as we continue exploring electrical safety and conclude our topic on making electricity. Until next time, I am Sir Zamin. Goodbye.